Tutoring leads to better performance. Two groups, a control group and an experimental group, took the same statistics exam. The two groups are taught by the same professor. The control group received no tutoring services, but the experimental group received weekly tutoring services. My question is, at 5% significance level, do you have sufficient evidence to prove that tutoring leads to better performance? So you are trying to prove something, right? So when you try to prove something, you put that inequality sign in HA. So you are trying to say the experimental group has better performance. So look at the data I gave you. Control group and experimental group. So you want to prove that experimental group has better performance. That means people earn higher score. So that means there is a greater than there is a less than in HA. The greater than is facing the experimental group. Now, before we write anything down, how do you know this is a T problem, not a Z problem? The answer is you do not know the population standard deviation or variance. You don't know sigma, then you use T. And the second question is, how do you know this is a two sample t-test, not a match pair? This is a two sample t-test because we have two independent samples, a control group and an experimental group. They are independent. If you are in the control, then you cannot be in the experimental group. You pick one. If you are in group 1, then you cannot be in group 2. Okay, now for the alternative hypothesis, we are going to say the first group is less than the second group. So we are going to write this down. So HA is mu1 less than mu2. And then H naught, so they didn't give me a sign, I will just take the opposite, so that will be mu1 greater than or equal to mu2. So that is your H naught and HA, and then you move on to the T, right? So you move on to the test statistics. So that is T equals to x1 bar minus x2 bar divided by, we have a, oh, by the way, there is another piece. So the complete formula is you have to subtract mu1 minus mu2. Some textbook, they don't write this out because you have an equal in H naught. So when mu1 and mu2 are equal, you subtract them, you will just get a 0. So that's why they just don't write this on the formula. And then S1 squared divided by N1 plus S2 squared divided by N2. So you get a test statistics and you also get a p-value. Other than that, you will get a degree of freedom. All right. Okay, the test statistics. So let's use our graphing calculator. So first of all, we go to stat and then we go to test. We hit the stat key and then you hit test and then you are looking for two sample t-test. All right, two sam t-test. Okay, and then we have stats. Then you choose the stats option and then you input the given number to your stats menu. So you have x1 bar 82, 13, sample size is 40, and then experimental group 91, S2 is a 10, right? So I gave you a 40. Okay, here. This is a mistake. It is supposed to be a 10. I copied this wrong. This is supposed to be a 10. The standard deviation is 10. So we have 91, 10, and 32. All right, so 91, 10, and 32 because my screenshot has 10 as well. And then what sign do you choose? Since you have a less than in HA, then you pick the less than. Remember, you have to get this right. If you pick the wrong sign, basically the entire problem is wrong. So you have 40 and 50 points all depend on this sign. All right, so make sure you pick the right sign. Read the problem carefully. Okay, so we pick a less than for HA, and then the poll I select a no. When do we select yes? The answer is when the question gives you a clear statement saying that they assume the two population variances or standard deviations are equal. Once again, if the problem say they assume, they don't have to tell you what it is, they assume the two population variances or standard deviations are equal, then you select a yes. Okay, so we have two options. Calculate, you get the p-value, the test statistic. If you hit a draw, then you will get this picture right over here. So this picture, what you are going to get is you are going to get a bell curve, and then the HA is a less than, so less than is a left-sided test. So therefore, the p-value, the shaded region, is on the left-hand side, and then the cutoff is where the test statistic is. All right. So if you look at your calculator, you hit draw, right? You don't see any region because the p-value is so small. And one of the reasons why I picked this problem is because, so let me hit calculate. So on my calculator, do you see that there is a very, very small p-value? But on your calculator, take a look at your p-value. Do you see that there is a -4 at the end? I want you to take a look at this, the p-value. You will see this on exams. So the p-value, do you see you have 7.17 and then a bunch of numbers and then followed by an E-4. So what is the E-4 mean? You can take a look at my screenshot as well. So what does that mean? This is a scientific notation. So the way you write this is, you write 7.17 times 10 to the -4. That means you have 7.17 and then you move the decimal point 4 steps to the left. So that is approximately equals to 0.0000717. My calculator just gave you the whole thing, but the graphing calculator, the TI84 Plus, they will just give you a scientific notation. I want you to be able to read this right on the test, because I have seen student write the p-value equals to 7.17. That is wrong. Okay, so make sure you don't make these mistakes on the test. Okay, so this p-value is so small, so this is less than 5% alpha, so therefore we reject the null hypothesis, right? Before we jump into the conclusion, let's finish this. So what's the t-value? The t-value or the test statistic is -3. Let's use 3 decimal places. So that will be 3.319. You add 1 to it, and that will be 320, right? And then very small p-value, the degree of freedom is around 69.91. There is a big formula to calculate the degree of freedom. If you want to know what the formula is, just watch the very first video. All right. Usually they will just not ask you to write the formula. They will just say, okay, whatever you see in your calculator, just write right there. Okay, now the p-value is so small. What do we say? We say that we reject the null hypothesis, and then the alternative hypothesis is true. That means we have enough evidence to prove that tutoring is good in, improving student score. All right, so let's write it down. I will just type it up for you. So since the p-value is less than, alpha is 5%, right? So 5%. We reject the null hypothesis, so reject, and conclude that the alternative hypothesis is true. What does that mean? Say something that everybody understands. That means we have evidence to prove that tutoring leads to better performance on exams. Okay, there you go. So we have a reject, and then what do I do? What's the next step? This is the end of the 2-sample t-test. So this line is the end of the 2-sample t-test. What we are going to do next is we are going to construct a confidence interval. So since we have a 5% alpha, right? So we have a 5% alpha, then we have to construct a 95% confidence interval. These two percentages, they must sum up to 100%. And then the formula is we have a point estimate, x1 minus x2, and then plus or minus t half alpha, degree of freedom, and then we have a square root s1 squared divided by n1 plus s2 squared divided by n2. And then to calculate the confidence interval, you have to go to stat, and then you go to test, and then you go to a 2-sample t interval. All right. So we go to stat, and then we go to test. We select a 2-sample t. Right. Don't select z. T interval. Okay, and then we stay with the stats menu. Looks like I have to input this. So the x1 bar is 82, right? So that is 82. And then s1 is 13, and then n1 is 40 students, and then x2 bar 91, and then s2 is 10, okay, 10, and then n2 is 32, and then the confidence level is 95%, so 0.95, so no pull. Once everything is ready, you just hit calculate. So this is calculate. So we have negative 14.41. I will just follow my screenshot, and then negative 3.593. What does that mean? I'm trying to do a verify. Verify what? Do you see that I make a conclusion using the p-value? I keep spelling the word verify wrong, so verify. What does that mean? Verify. Verify means I just make a conclusion using the p-value, right? Less than alpha, we reject H0. Now, what I want you to do is I want you to use the confidence interval to reject H0. How do you do it? First of all, we recall the H0, which is mu1 less than or equal to mu2, right? So if you subtract mu2 on both sides, that means mu1 minus mu2 is greater than or equal to 0. Let me give you a simple math. So let's say 10 is greater than or equal to 1, right? That means 10 minus 1 is greater than or equal to 0. That's how simple it is. And then next, I would like you to look at this 0, greater than or equal to 0. So greater than means positive, 0 means 0. Now, what is the purpose of constructing a confidence interval? The purpose is we are trying to say that the truth is between those two numbers. Then what is the truth? You just make a claim. You claim H0 is the truth, right? You claim that greater than or equal to 0 is the truth. Now, the question is the greater than is positive and 0 between those two numbers? Answer me. Is 0 between negative 14 and negative 3? No. Is positive numbers between negative 14 and negative 3? No, right? So that means this H0 is outside the confidence interval. I need to see this on your paper. Is outside the confidence interval. So that means H0 is not the truth, right? You are saying that the truth is between negative 14 and negative 3. It turns out that the H0 is not the truth. So that means H0 is not true. Then you reject H0. That's how easy the verification is. Take a look. We reject H0 using a p-value, and then we reject H0 using a confidence interval. That's what I want people to do on the test every single time. And one other thing is, how do you explain these two confidence intervals? I just said that the truth is between them. Okay, so let's type this. So we are trying to explain the confidence interval, right? So let me type this for you. So we are trying to explain the confidence interval. How? Here is the correct language. You have to say that we are 95% confident that we are on average tutor student earn additional points on the test. So tutor students earn additional around 3 point, how many? Like 3.6, I round a little bit to 14.4 points on exam. So tutor students earn more on exam, around 3.6 to 14.4. So if you are trying to persuade students to tutoring, you just say that, okay, based on the previous study, if you go tutoring, on average, you can earn additional 3.6 to 14.4 points on exams. This is how we explain. So let me be very clear. Explain and verify, they are not the same. Explain is the correct language for explain is we are 95% confident, whatever, blah, 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 blah. And then for verify, you have to use the language like inside or outside the confidence interval. All right, so that is the end of this problem. If you think my instruction is helpful and clear, give me a like, share, and subscribe. As always, stay tuned. I will see you all in the next one. Signing out.